Let's do this question. Find for the given network, find the power supplied by the dependent voltage source. Okay, so here you can see that this is the dependent voltage source. Okay, this is the only dependent voltage source, and this is a dependent current source, and this is an independent current source, right, whose value is 5 ampere. The value of this dependent voltage source is 0.4 V1, and the value of this current source is 0.01 V1, right? But what is V1? Let's see what is V1. V1 is the, yes, V1 is the voltage across this current source, right? V1 is the voltage across this 5 ampere current source, right? So what is the question now? Find the power supplied by the dependent voltage source. So that means find the power supplied by this source over here. So what is the equation for power? Power is V into I, right? V into I is the power, voltage into current. So what is the voltage over here? Voltage is 0.4 V1. So 0.4 V1 is the voltage over here. And what is the current in this branch? Well, if you are marking I1, I2 and I3, right? So let this be I1, let this be I2, and let this be I3. Okay, so in that case the current through this branch is I1 minus I2, so which means the current through this branch is I1 minus I2, right? So this is the equation for the power supply, right? That is 0.4 V1, which is the voltage across this, into I1 minus I2, which is the current across this. So V into I, so which means you need to find the value of V1, you need to find the value of I1, and you need to find the value of I2. Then only you can find the value of the power. That's this circuit, right? So let's do this question right now. This question, let me tell you now what is the difference between this question. In this question, if you look at mesh 1, right? If you look at mesh 1, there are two ways of writing mesh 1, right? One is your ordinary way of writing in terms of I1, and the other is by applying Kirchhoff's voltage law. The reason why you can apply the Kirchhoff's voltage law over here is because in this current source already they have given the voltage across this current source, right? V1 is the voltage across the current source. So since they have given the voltage also, that means I can write this equation mesh 1 in two ways. That's what this means. Let's see it later. So let's write the equation for mesh 1, right? So equation for mesh 1. Okay, so what is the equation for mesh 1? Here there is a current source called as 5 amperes in this branch, and the same branch the name of the current is I1, which means the equation for I1 is, or the equation for mesh 1 is, I1 is equal to 5. This is the equation for mesh 1, right? Now what is the equation for mesh 2? So equation for mesh 2, okay, is, so here also you see, here also there's a current source over here, right, in this branch, and it's going upwards, whereas your I2 is going downwards, right, opposite direction. So therefore in this branch the current is I2, and the same current is 0.01 V1, which is going upwards, which means the equation for mesh 2 is I2 is equal to minus 0.01 V1. This is the equation for I2, right? So now I found the mesh 1 equation, I found the mesh 2 equation. Then let me write the mesh 3 equation. Equation for mesh 3, which is nothing but, let me see, I1 is touching only this resistor, which is minus 20 I1, and what about I2? It is touching only this resistor, so it is becomes minus 30 I2, and what about the I3? It is touching all the three resistors, right? 20 plus 30 plus 50, 100 plus 100 I3 is equal to 0, right? So now we have the mesh equations, right? But how many unknown variables are there in the circuit? I1, I2, I3, and V1, right? So there are 4 unknown variables, which means you need to have 4 equations. You already wrote the 3 equations, so you need one more equation, and that equation is used for defining V1, right? V1. But what is V1 over here? V1, like I said before, V1 is the voltage across this current source, right? Voltage across this current source. So what I'm going to do is, I'm just simply going to apply my Kirchhoff's voltage law in this mesh. Yeah, the old fashioned way, I'm just simply going to apply my Kirchhoff's voltage law in this mesh, which is equation is KVL of mesh 1. Kirchhoff's voltage law of mesh 1. What is it? That is the voltage drop across this plus the voltage drop across this is equal to voltage source over here. That is the Kirchhoff's voltage law. So what is the voltage drop over here? Voltage drop over here, what the resistor is 20 ohm, and what is the current over here? Current is, in this branch, the current is I1 minus I3, right? So therefore the voltage across this 20 ohm resistor is 20 into I1 minus I3. This is the voltage drop across this resistor. Now what is the voltage drop across this 5 amperes? What is the voltage drop across this? It is minus V1 is equal to, why it is minus V1 and not plus V1? That you should understand. We should be very careful when you're writing all this, okay? Why it is minus V1 and not plus V1? Why is voltage drop considered as negative? You see that you need to understand that. See, suppose, okay, instead of a current source, I'm going to draw a resistor, okay? Instead of a current source, I'm just going to draw a resistor, and I'm saying that the voltage across this resistor is V1. Okay, I'm saying the voltage across the resistor is V1, and I'm saying that the polarity of V1 is plus over here and minus over here. This is the polarity of V1, okay? And then I'm saying that the current over here is I1, which is flowing from left to right, okay? So if you look over here, we know that current, or in any circuit, current always flows from a higher potential to a lower potential, which means that this voltage drop over here is positive. Right? That's what this means. That means this voltage drop is positive. Now, if I take the same scenario, okay, if I take the same resistor and the voltage across this resistor is also V1, but this time the polarity is different. This minus is over here and plus is over here. And I'm saying that the current is still flowing from left to right, I1 minus I2, okay? So, but we all know that in any circuit, current flows from a higher potential to a lower potential. But here, my potential is opposite. The polarity is opposite, which means that this sign over here, that is the sign of this voltage drop, is the opposite to the one that I have assumed, which means the voltage across this resistor is minus V1. That is why the voltage across is minus V1. So if you look over here, this current I1 is flowing from a lower potential to a higher potential, okay, which means the voltage drop across this is negative, okay. One more, I want to tell you, this is not a voltage source. This is a voltage drop like this. This is just like a resistor whose voltage across the resistor is V1. That's what it means, right? This is a voltage source, but this is a voltage drop, and the voltage, which means the voltage across this element is, it doesn't matter which element it is. It can be any element, but here it is 5 amperes. It can be any element, but the voltage across the element is V1, okay? And since this current is flowing from a lower potential to a higher potential, that is why the polarity, that is why the drop over here is considered as negative. That is why we put a minus V1 over here, okay? So is equal to, now let's see the voltage source. This is the voltage source. This is the only voltage source over here, right? And in this voltage source, the current I1 is flowing into the positive terminal, which means this positive terminal is not generating current, it is opposing current. Therefore, it is minus 0.4 V1. Right? This is the equation. So now I wrote my 4 equations, right? Now I need to solve them. But so now what do I need to find? I need to find the power. To find the power, I need to find the value of V1. I need to find the value of I1, and I need to find the value of I2. I already found the value of I1, right? I1 is already given. I1 is equal to 5. And also I2 is equal to minus 0.01 V1. I2 is equal to minus 0.01 V1, or I can also say that V1 is equal to, let me see, minus 100 I2, right? V1 is equal to minus 100 I2. So now I found the equations over here. You can solve this in any way you want. All I need you to find the value of V1, I1, and I2. You don't have to follow the same procedure. Okay, you can find in any format you want. Okay, so what I'm going to do is, so since I need to find the value of V1, I1, I2, which means the one parameter which I don't want is this one, I3. I don't want find the value of I3. right? So what I'm going to do is that I'm going to equate both this equation in terms of I3, and then I will equate both of them, right? So here, what is the equation for I3? I'm going to say that equation of I3 is 100 I3 is equal to, this will become 20 I1 plus 30 I2, right? This is the equation of I3. And what about over here? What is the equation of I3 over here? Let me see. It will be 20 I1 minus 20 I3 minus V1 is equal to minus 0.4 V1, or let me see that if I put 20 I3 over here and 0.4 V1 over here, then this will become, let me see, 20 I3 is equal to, this will become 20 I1, right? 20 I1 minus 0.6 V1, right? Is V1. So this is, so now I found these two equations in terms of I3. Maybe I, instead of, maybe I'll make this equal. So what I do is I will multiply this equation into with 5. So this will become 100 I3 is equal to 100 I1 minus 0.6 into 5 is 3, right? So 3 V1, right? So which means 100 I3 is equal to 20 I1 plus 30 I2, and 100 I3 is also equal to 100 I1 minus 3 V1. So what does it mean? It means that these two are equal to each other. Or in other words, 20 I1 plus 30 I2 is equal to 100 I1 minus 3 V1. Okay, this is what it means. But V1, I already know that V1 is equal to minus 100 I2, right? So I'm going to substitute that with, I'm going to substitute this V1 with minus 100 I2. So what this will become? It will become 20 I1. Let me see, 20 I1 plus 30 I2 plus 30 I2 is equal to 100 I1, 100 I1, and what about this one? Minus 3 V1, but V1 is minus 100 I2, right? So minus of minus becomes plus. So this becomes plus 300 I2. So plus 300 I2, right? Or in other words, I can say that 30 minus 300 is minus 270 I2 is equal to, and what is 100 minus 20 is 80. 80 I1, right? Or in other words, I2 is equal to, what is I1? I1, we already know I1 is equal to 5, right? I1 is equal to 5. Therefore, 5 into 80 is how much? 400. So which means this is minus 400 by 270 amperes, right? Maybe I can remove the 0 over here. So this is nothing but minus 40 by 27 amperes. Okay, I'm not going to write it in decimal numbers. If you want, you can write in decimal numbers. That is your choice. I want my answer to be very accurate. So what I'm going to do is I'm not going to represent this in terms of decimal numbers. I will just simply use this fraction as such, and then finally only I will write it in decimal numbers. Okay, that's what my plan is. You don't have to follow that same plan. You can write your own way. Okay. So I2 is equal to minus 40 by 27, and I also know that I1 is equal to 5 amperes. And what about V1? V1, yeah, V1, according to here, V1 is equal to minus 100 I2, right? V1 is minus 100 I2. Let me write that over here. V1 is equal to minus 100 I2, which is a minus of minus is plus, so which means this is nothing but 4000 by 27 volt. That is the value of V1. V1 is equal to 4000 by 27 volt, right? So therefore, now I found the value of V1, I found the value of I1, and I found the value of I2. So now I can find the value of power. So therefore, power supplied by the dependent voltage source is equal to V into I, right? And what is the value of the voltage? Voltage is, according to the question, the voltage is 0.4 V1. So 0.4 V1 is the voltage. And what is the value of the current? The value of the current is the current through this branch is I1 minus I2, which means the current over here is I1 minus I2, right? or this is nothing but 0.4. What is V1? V1 is into 4000 by 27, okay, into, and what is I1? I1 is 5 minus, and I2 is minus 40 by 27. Minus of minus is plus, which means it is plus 40 by 27. This is the equation of power. Okay, let me see. Which means you will get 0.4 into 4000 divided by 27, right? Divided by 27 into bracket 5 plus bracket 40 by 27. 40 divided by 27. Close the bracket and close the bracket again, and you will get this value, and this decimal number is 384.088 watts. This is the equation of, this is the answer for power. Okay, this is how you do the problem, right? So the only difference between this problem and previous problem is that you can express this mesh 1 in two ways, right? You can express this mesh 1 in two ways. One is by this method, that is your normal way of applying, and the other way is by using Kirchhoff's voltage law. Okay, that's the only difference. So this one mesh can be written in two ways. That's the only difference in this problem. Okay.